Students, let's look at this question, which is on PNC. I believe taken from RI PNC tutorial question 10. Okay, let's say we can do this professionally. So the 8 people go to a theater and sit, okay, in a particular group of 8 adjacent reserved seat in a row. Three of the 8 belong to one family and sit together. Okay, so you're told to, if the other 5 people do not mind where to sit, find the number of possible seating arrangement for all the 8 people. I think this is pretty okay. I don't think this should be 4 marks. This kind of question likely is not 4 marks anymore, probably 2 marks. Okay. So for the first one, you have got 8 of the people. So this is 1, 2, 3, 4, 5, 6, 7, 8. Now, this is 8 of them, and 3 of them have to sit together because this is a family. Then the other 5 don't mind sitting wherever. So you just 1, 2, 3, 4, 5. From here, we just need to calculate the outer entity will have 1, 2, 3, 4, 5, 6. So this is 6 factorial. Then within the family, you have got 3 factorial way of arranging them. So the number of ways is just going to be 3 factorial multiplied by 6 factorial, which is 4, 3, 2, 0. Great. So let's look at part 2. So A part 2, if the other 5 people do not mind where to sit, except that 2 of them refuse to sit together. Now, 2 of them, meaning to say this is predestined already. So the 2 is just 2 choose 2. You don't need to 5 choose 2, because this 2 could be John and let's say Charles. So they predestined. So bring them out, find a number possible seating arrangement. So you just slot them in, right? Same thing. I don't think this is worth 5 marks anymore. This kind of question typically will worth like 2 marks, okay, or at most 3. So what we're going to do is just arrange the 1, 2, 3 and the family of 3, 1, 2, 3. So this is family here. Okay, family. And this is the other 3, 1, 2, 3. So if I were to permutate them, is 1, 2, 3, 4. This is 4 factorial. Okay, within the family, this will be 3 factorial because you can arrange them. Now remember, then after which you bring the other 2 in, you could just choose the separation slot 1, 2, 3, 4, 5. There are 5 slots they can choose from. You could just 5 choose 2 for them. Now remember, when you choose the separation slot, you don't arrange them, right? When you choose the separation slot, what you do is you just highlight the slots that they should be slotted in. Then after which you must understand these 2 other people, you could permutate. Okay, so this is 5 choose 2 multiplied by 2 factorial. Or if you do not like to write this way, you can just write 5p2 as well. It's the same thing. Okay, so just multiply them together. This will be 2 factorial multiplied by 4 factorial multiplied by 5 choose 2 multiplied by 2 factorial. They'll give us, 3 factorial. The family of 3. Yeah, I keyed wrongly. I wrote wrongly. They'll give us 2880. Great. Let's look at part B. Now, part B is something which we've gone through in class before. It's in our notes, right? Remember, this is a very standard question, okay? So it's the same as, like, let's say you go a picnic, you want to bring the types of fruits, right? The number of types of fruits. So the salad bar at the restaurant has 6 separate bowls containing lettuce, tomatoes, cucumber, radishes, spring onions, and beetroot, respectively. Okay, John decides to visit the salad bar and make a selection. At each bowl, he can choose to take some of the contents or not. Assuming that John takes some of the content from at least one bowl, meaning it couldn't be an empty bowl, find how many different selections he can make. Okay, great. Now this problem here, there are 2 methods to do this. There are really 2 methods to solve this. But usually I'll tell my students that the best way is always the method number 2. Okay, I'll prefer students to think from the perspective of the ingredients rather than from the perspective of John. So how do you think about it? It's pretty simple considering cases. If you have got 6 of these ingredients here. So you have 6 of these ingredients. You have lettuce, tomatoes, cucumber, radishes, spring onions, and beetroot. What you need to understand is just understand that you could from these 6, you can just 6 choose 1. That's one way, meaning to say John could have just taken 1 content, right? Then you could add 6 choose 2, which means you can choose 2, then multiply 6 choose 3, 6 choose 4, 6 choose 5, add 6 choose 5, and 6 choose 6. This is usually what is preferred by students because this is very intuitive because you're thinking from John's perspective. But the problem with this, one problem with this method is that you imagine if you have got you have like 100 100 100 dishes, then you will have to 100 choose one all the way to 100 choose 100. Not that you couldn't use a GC, but there's a more elegant way of doing it, because then you couldn't find the exact value, okay, for a larger number. So when you key in calculator, this will be 63. Okay. So what I tell students to do is to think from the method 2. Think from the perspective of the content. From here, what you need to understand is that if you think about it from the letters perspective, imagine if you're on the salad bar, you could only look at John walk in, and there are only 2 outcomes you could have, meaning either you're chosen or you're not chosen. Okay. Then you move on to tomatoes. You think from a tomatoes perspective, there's only in or out for tomatoes as well. Then cucumber, there's also in or out as well. So all of this has only got 2 choices, meaning either they are chosen or they're not chosen. Okay, so what I need to visualize is actually this is a massive tree diagram. It's not just a simple diagram like that, meaning to say it could be letters in, out, then after that, all the letters will branch into, each of these branch will branch into 2 for tomatoes, and just branch. Okay, so it's a massive tree diagram with a lot of branches. But the idea here is very simple. Say for example, if say you John just want to pick cucumber and spring onions, it could be out, out, in, out, in, out, out. This will correspond to where John will be taking cucumber and spring onion only. And say John just want beetroot, it could be out, 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 in. Okay, so this branch will consider where he just takes beetroot. It could also mean that John take everything in, which is like everything on the bar, the 6 of them. Okay, but this also will include where John doesn't take anything. Okay, so if we consider the number of ways, basically the number of branches you have is 2 times 2 times 2 times 2 times 2 times 2 times 2. So they're like 6. That's 2 to the power of 6. 2 to the power of 6. You get then you remember to minus of 1. Okay. Minus of 1 because you need to consider the case where John doesn't take anything. In the question, they want John to at least take 1. Here we get 63 as well. So method 2 is a preferred method. Okay, just remember that. Okay, let's look at B part 2. John decides he's going to have 4 salad items, and one of them has to be tomato. How many different selections can he make? I think it's pretty okay. So what we need to understand is tomato is already predestined, so it's 1 choose 1. The 3 others, you have 5 of the other content to choose from, so it's 5 choose 3, right? Okay, so the number of ways is just 1 choose 1 multiplied by 5 choose 3, then this will give us a grand total of 10. Okay, so that's how we do this question here proficiently. If you have any questions at all, please do let us know, and I'll see you in the next question.